So let's say we have to generate a structure that has 1 unit of unsaturation. So our given molecular formula is C5H10, which would be 1 unit of unsaturation. What we do again is we start with a 3-carbon framework. So we start with this. But what you have to keep in mind is that from the get-go, because you have 1 unit of unsaturation in this case, you also have to generate a ring structure. So in this case, we don't start with just one structure in the C3 case, but we actually have 2 already. So when we move on to the C4 case, we again can do the same thing as we've done before. We can extend our carbon chain, and it can either be here or it can be there. So we generate 2 new structures from this. So we generate the branched structure, which looks like this, plus we also generate the fully linear structure, which looks like that. But on top of that, we can now also generate an extended ring structure, and really you can attach it anywhere to the ring because they're all going to be the exact same isomer. So now you also generate this methyl cyclopropane, and on top of that you have to keep in mind that it's now 4 carbons and 1 unit of unsaturation. So really what you can do is you can also think about drawing a 4-membered ring. So as you can already see, this increases the amount of constitutional isomers that we can draw quite a bit. So now if we just do that again for our non-cyclic structures, we end up with the ones that you've already seen before, and you know that 2 of them are actually going to be the same in the C5 case. I'm just going to draw it down here now. So for C5, we end up with this structure plus the fully linear structure plus the branched structure like this. So then if we look at the cyclic structures that we've just generated, there are a few different options. So you can either attach another methyl group here, generating the C5 structure. You can also generate another methyl group there, generating a C5 structure. Or you can generate another structure by adding 1 methyl group there. So let us look at the different structures that we get from that. So we get 1 methyl cyclopropane that is, or we get a dimethyl cyclopropane really. We get a different dimethyl cyclopropane. And lastly, we get an ethyl cyclopropane. And then we also have to think about the cyclobutane that we've just generated, which looks like this when we extend it. And there is nothing else really we can do with that because this is the only way, and the other ones regenerate the same constitutional isomer. So we end up with a structure that looks like that. Keep in mind that if you have 5 carbons and you also have 1 unit of unsaturation, it is very possible to also draw a cyclopentane ring. So this is another structure that we can get. Now lastly, we have to think about the fact that we actually have to stick 1 unit of unsaturation in here. So the structures that aren't cyclic, they will need to have a double bond. We don't have any other functional groups in here, so it has to be a double bond. Now if you look very closely, the completely branched structure, this one, the one that I'm just marking in red, it cannot have any double bonds without you generating a Texas carbon. So we do not want this structure because we can't do anything with it. The other structures, I'm just going to redraw them now. Down here. The other structures, we can add double bonds to. And we have a bunch of different options here. So we can either add a double bond here, or we can add a double bond here. This would be the same, and this would be again the same. So let's look at the 2 different structures we get from that. So we get this structure, and we get this structure. And these are the only two. Now keep in mind that in this case, there would be a cis and a trans isomer. So you would also need to generate this one, because they're different. On the other one, we can attach a double bond here, we can attach a double bond there, or we could attach a double bond here. So let's look at the different structures we get through that. I'm gonna have to squeeze them down there. So that would be this structure plus this structure plus this structure. Now, in this case, because we have two similar substituents on either side, we actually cannot define cis or trans, or even E and Z, what we're going to talk about next week. In this case, because there are again two hydrogens, and here too there are two hydrogens, you cannot generate any other structures other than these. So now, after you've generated all the structures, you quickly want to check if there are any structures that are similar that you cannot use, and you will find that these are all the structures that you can actually generate. So C5H10 with 1 unit of unsaturation will have a total of, and I'm going to just mark them all in red, we'll have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 structures. So that was isomer generation in a systematic way by with 1 unit of unsaturation.